Hey guys, I wanted to go over graphing trig functions and do some practice problems with you. So yesterday we talked about the different transformations, the first being the amplitude. The change in amplitude changes our max and min. So on the parent graphs of sine and cosine, the maximum and minimum are at 1 and -1. When I multiply a number by the trig function, or multiply a number by the trig function, which is where a is located, it changes the amplitude. And so the amplitude becomes a. So instead of being at 1, now my maxes and my mins are at a higher or lower point. All right. And I also want to just take a second. If a is negative, guys, that is going to be a reflection. So instead of starting up high on sine, for instance, we're going to start down low. Okay. And instead of starting low for the min on the second point, we'll go up high. Okay. So whenever you have a negative amplitude, you're going to just have a reflection, but you'll still be moving up to whatever a is. So if a is -3, that means my max and min points are going to be at 3 still. I'll just put a reflection. All right, let's go over to 2 pi over b, which is the period. So a period is how long it takes for our functions to do their cycle. And if I go back over here and I look at sine, this is a sine curve, right? It's that sideways S. Sine will start at 0. It does the sideways S thing. And then when it ends, its cycle is at 2 pi. Because now at 2 pi, if we keep going on, it'll start doing the sideways S thing all over again. All right? So think of the period as your cycle, how long it takes for the cycle to occur. Over here, we have a cosine graph. Remember, cosine starts up high, okay? Now, on a normal period of cosine, it goes high, it goes down, and it makes this V, and it ends at 2 pi as well. Okay, so our parent graph on cosine ends at 2 pi before it starts that V cycle again. Now look, notice they did a period change here, and let's see how long it takes for it to do its cycle. It looks like it is taking a whole 2 pi over 3 for it to do the cycle. Bam, bam, and then again. All right. So our cycles or our periods are smaller now. Okay. You're going to find your period change by taking b, which is the number that's being multiplied by the x, and putting it under 2 pi. Okay. So whatever that number is, we'll put it under 2 pi. We are going to practice that as well. Phase shifts. Phase shifts is the shifting of the graphs to the right or the shifting to the left. And we're going to find our phase shift by looking at this number C here. So whatever is being subtracted from the X, we'll take that number C and we're going to divide it by our B value. Okay. Remember, subtraction shifts the graph over to the right and addition shifts it to the left. It does the opposite of what you feel. All right, let's go over to D, and we're going to talk about the vertical shift. And our vertical shift is going to shift the entire graph up and shift the entire graph down. The vertical shift is this D value, if you look back up here, and it's what's being added or subtracted from the entire function. All right, guys, this is very similar to our transformations that we did back in the day, right? The only difference is now we're using sine, cosine functions. All right, let's go to the practice problems and let's review some of the practice problems. Okay, let's look at A, and I want to move this down. If I look at A says find first the amplitude. And if we look, remember, we're going to be looking for that number that's multiplied in front of the trig function. So here's our trig function. A is that, or the amplitude, sorry, is the number that is being multiplied in front of the trig function. And before we get, I kind of jumped into this, but what I want to do actually is I'm going to set this up again, what we had on the first page, so that we know what we're looking for. Remember, this is going to be as D plus A times cosine, or it could be sine, of BX plus C. Okay, and I have Y equals. Okay, so this way we can realize what we're looking for. So remember, our amplitude is going to be the A. So we're looking for that number in front. So my amplitude for this function should be 4. Now it is not negative 4. That negative is just telling me that when I graph it, I'm going to be putting a reflection on the graph. Okay, let's talk about my period. I find the period by looking at B. Okay, and what I'm going to be doing when I find my B value is I'm going to take 2 pi divided by whatever B is. Okay, so our B value is whatever's in front of the X, or being multiplied by the X. In this case, it's 2. So I'm taking 2 pi divided by 2. 2 pi over 2 is just pi. So I know my period is equal to pi. Okay. Phase shift. Phase shift, I'm going to be taking C and dividing it by B. All right. We already know that our B is equal to 2. Okay. So what is our C? Well, our C is whatever is being added or subtracted to the X value. So if we look inside right here at X, pi is being added. So we know that our phase shift is going to be pi over 2. Here's the deal though, are we shifting to the right or left? Well, look, we're adding. So that means that this is going to be a shift to the left. So we're moving to the left pi over 2. Okay. And let's talk about our vertical shift. And I'm going to erase some of this stuff. Vertical shift is what is being added or subtracted to the entire function, or our D value. If we look at this, is there anything being added to the entire function? No. All right. So there is no vertical shift. All right, let's go to the next one. Again, we're going to find the amplitude first, and our amplitude is the number that is being multiplied by the function, or the number right in front of the trig function, or A. So for this one, and I want to change the color, our A, or the number in front of the trig function, is 1/2. And I'm going to change it again because that is not the best color for this. There we go. So it is 1/2. Now let's talk about what our period is. Remember, period is B. We're going to look at what the B value is, and then we'll take 2 pi and we'll divide it by our B value. So in this case, our B value, or the number in front of X, is, and you got to be careful, but B is all of this stuff. Okay, so it's 2 pi over 3. So our B value is a fraction. So we're going to take 2 pi and divide it by 2 pi over 3. And guys, I'm going to use some more of my space over here. But remember, that's just keep, change, flip. So I got 2 pi. I'm going to change to multiplication. I'm going to flip the fraction, so this is really 3 over 2 pi. So when I multiply this across, the 2 pi's cancel, and I end up with just a 3. So my new period is 3, and let me just erase this. And I'm going to put some space over here, so I can write that down, that my period is equal to 3. All right, let's talk about the phase shift. Phase shift is C over B. We're going to be doing some more keep change flip. Remember, we already know that the B value is 2 pi over 3. And what is our C? Do we have a C? No, we don't. So is there going to be a phase shift? So our C is 1, essentially. So there's no phase shift on this, right? Because it's not 1, I'm sorry, it's 0. It's nothing. So there's no phase shift. There is none. No phase shift. Okay? All right, let's go to our vertical shift. If we look, vertical shift was D. Is there something being added to the entire function? And if we look, we have 5 being added to the entire function. So we know the vertical shift is 5. And it's added to, so it's going to move the whole entire function up 5. Up 5 units. All right, let's look at the last one. We're going to find our amplitude first. And amplitude is the number that's multiplied by the trig function. So my A in this case would be 2. And it's this 2 right here, right? The number multiplied by the trig function. Now I need to find the period. Period is 2 pi over B. So what is our B value? Our B value in this case, the number being multiplied in front of the X, is the 1/2. So I'm taking 2 pi divided by 1/2, and you guys could probably do the keep change flip in your minds. This would be flipping the 1/2. Okay, so that way means we'd be taking 2 pi times 2, which would be 4 pi. So our period is going to be 4 pi. All right. Now let's talk about what the phase shift is. In this case, we do have a phase shift. We have a number being multiplied by, not multiplied, I'm sorry, being subtracted from the X. Okay, so our phase shift is going to be here. So we're going to take C and divide it by B to figure out what that phase shift is. We already know our B is, and I'll use another color, our B is going to be 1/2. Okay, that is this number. Our C is the pi. Okay, I'm not worrying that pi is negative. The negative part just tells me what direction I'm going. Remember our keep change flip. So this is going to flip up. So I would end up with 2 times pi, which is just 2 pi. All right. So our phase shift is 2 pi. And remember, it's negative. So are we moving to the left or the right? And if you said we're moving to the right, you are right. So we're going to be moving to the right 2 pi units. Okay, so 2 pi units to the right is going to be our phase shift. Now, I am going to do our vertical shift over here because I'm running out of space, and I'm going to use another color. Let's go with green. Okay, remember vertical shift is this D value up here. So if I talk about the vertical shift for this function, it's something being added or subtracted from the entire function. And the answer is yes, right? We have this -2 being added to the entire function. Now don't get confused. That -2 is negative, right? So that is going to